This is Dante with Paths in Math. Welcome to our second part of the SAT formula sheet. On the SAT, you're going to want to save as much time as possible. You only have an average of a minute and a half per question. To save time, you can memorize some of these things from the formula sheet. The first thing I'll teach you is the area of a triangle is half the area of a rectangle. And we all know the area of a rectangle being base times height. Now what's interesting about this is no matter where you create that triangle, as long as it's touching two corners and the opposite side, it's going to be half the area every single time. And that's where they derive this formula from. Another thing that's interesting is the angles of the triangle add up to 180 degrees, which may not sound too familiar, but this is a very important concept that you need to know for the SAT. This derives from a triangle being half of a rectangle. In case you don't remember, the angles of a rectangle are all 90 degrees, but they add up to 360. Maybe now you can see the correlation between the 360 degrees of a rectangle and the 180 degrees of a triangle. Hopefully that can help you remember what those angles add up to in a triangle. It's half of a rectangle, okay? You can use that. Furthermore, one thing that I feel like a lot of students don't realize is the volume of a square pyramid being very easy to memorize. It's the volume of a cube, length times width times height, or even a rectangular prism, but you divide it by 3. That's all it is. You just take the volume of a rectangular prism and divide it by 3. This is similar with a cone. We covered cylinders, cones, and spheres in part 1. I'll put the link down below. A cone, or a cylinder, let's start off with that. The volume is pi r square h. A cone is pi r, the volume of a cone is pi r square h divided by 3. Both the cone and the pyramid end at a tip, like a triangle. And so that's a correlation that those have. So very, very helpful tips that could save you arguably minutes, because you don't want to thumb through the formula sheet and through all that math work every time you want to double check something. So it's important to have those in mind. The first thing you want to identify on the SAT problem is the question that they're asking. In this case, they're asking for the area of a triangle. So we know we have to use the formula 1/2 base times height. Now we have to derive the base and the height. They give us a diagram, thankfully, and they describe a rectangular piece of paper being cut into the shape of a triangle. They give us the dimensions of that piece of paper, so let's label that onto the diagram. With this being done, we can see that the height actually correlates with the height of the triangle. The height of the rectangle correlates with the height of the triangle, so we can plug in our values that we know. It's 1/2 times 10 times 7. That's going to be 35. So 35 square inches is the area of the triangle. We have to find the area of a triangle again. In this case, they specified triangle ABC, so we have to read that properly. We have to understand that the triangle that they're asking for is not one of the smaller triangles, but rather the entire large triangle. So hopefully right off the bat, you can notice that the 4 and the 8 can be combined to give us 12. I know that line segment AC is 12. Let's use the unit of measurement of feet for this problem. So we know it's 12 feet, but we still need one other length, and that's going to be the height of this triangle. The height can be determined as being this line right here. If we treat AC as the base, we could treat that line segment as the height. I can quickly determine that the height is 3, and that's because I know my special triangle. Sorry, it's not a very good triangle. They gave us 4 and 5 for this little segment here. I'm going to take out this segment, ADB, or ABD, triangle ABD, and I'm going to show you how this side right here is actually 3. Now we can use Pythagorean's theorem, which is a squared plus b squared equals c squared. That would be 4 squared plus x squared equals 5 squared, because hypothetically we didn't know this. We get 16 plus x squared equals 25, and x squared equals 9. So x equals 3 when we take the square root of both sides. That's the proof, but that's going to take a lot of time on the SAT. The 3, 4, 5 triangle, which is part of the SAT formula sheet, is a very important triangle to know because it can help you save so much time avoiding all this work. As soon as I identified a few key details, I could tell it was that side was 3. First of all, we have a right triangle. You need a right triangle in order to determine a 3, 4, 5. We need 2 of those sides to match this sequence. So the hypotenuse has to be 5. In this case, it is. The hypotenuse has to be 5. And if they give you either one of these other sides, being 3 or 4, then you know that the other side is going to be the corresponding amount. So they gave us a triangle with 3 and 5 as a hypotenuse. I know that 4 is the missing side. And this scales up. We could do 6, 8, 10. We could even do 12, 16, 20, and all sorts of other ratios involving that, other scales involving that ratio. So that's going to save us a lot of time knowing that on the top of our heads. Very important to practice the special triangle 3, 4, 5. Since I know that this line segment right here is 3, that's my height. I know that's my height. My height is 3 feet. Now I could apply that into the formula. 1/2 times 12 times 3, and we get, that's going to be 6 times 3, so that's 18 square feet for the whole triangle. Here we have a triangle inside a circle, which the SAT does love to utilize. They're going to ask for the area of the triangle HJK. They gave us the diameter of the circle being 14, and they told us something that's interesting. They said that the line segment HK goes through the center of the circle. What that means is HK is the diameter of the circle. Okay, that does count as the diameter of the circle. So I could quickly label that as 14, that line segment, which is important because that's half of what we need, right? We know that the base is 14, the base of our triangle. But what about the height? How can we determine the height of this triangle? I want to talk about these symbols that are on this triangle. There's 2 dash marks on the side lengths, and there's 2 rainbows, you want to call them, or curves, indicating that these 2 angles are the same and these 2 line segments are the same length. So this is an isosceles triangle. Now, they don't tell us that, but they indicate that it's an isosceles triangle with those symbols. That means that the 2 sides, the 2 legs of the triangle match, and the 2 angles, the base angles of the triangle match. This helps us determine the height of the triangle being the radius, because we know that from the center to the top, the center of the circle to the top of the triangle is actually just a straight line from the center of the circle to the circumference of the circle. Now, we know the radius because they told us the diameter. The radius is always half of the diameter. So my radius is 7. Since I know my radius is 7, I also know that the radius is the height of the triangle. I could plug that in to my work. That's going to give us 49 square feet as our answer. In this problem, we can't assume that this is a right triangle. They did not present to us or give us a box in that corner, so don't assume any angles just based on the diagram. They told us 2 angles. The measurement of angle A is 17, and the measurement of angle C is 23. Now, they want us to find the measurement of angle B. We know that the correlation of these 3 angles in a triangle, in any triangle, is that they add up to 180. So I'm going to set up an equation that represents that. I'm going to let X represent the angle for B, the measurement of the angle B. This is all set equal to 180. So I'm going to add these 2 first. That's going to give me 40 plus X. And then I'm going to move the 40 to the other side by subtracting it, giving me 140. All right, so I let X represent the measurement of my angle B. My answer is 140 degrees. This is a harder version of the problem we just practiced. They gave us the measurement of the angles, but they gave it to us in forms of expressions. So for example, angle A is 3x minus 20, angle C is 2x minus 10, and they actually gave us the value, the whole value for measurement of angle B. Regardless of what they give us in expression form, the property that we've been using remains true. All of these add up to 180 degrees. So let's represent that as an equation. I'm going to add the 3x minus 20 with the 2x minus 10, and I'm also going to add in the 130 and set all of that equal to 180. Okay, so it looks like a mess at first, but hopefully you're comfortable with combining like terms. I see that the 3x and the 2x are going to combine. They're both positive, so it's going to be 5x. There's also the negative 20, the negative 10, and the 130. I'm going to box those. That's going to combine to 100. A positive 100. So very quickly we simplified this expression. We have to solve for x. We have 5x equals 80, and x equals 16. So I found out x equals 16, but is that my answer? Is the measurement of angle A 16 degrees? No, in this case, x does not represent the measurement of angle A. X is just a variable. It's a part of the expression that we need to solve for angle A. Okay? X does not represent the actual angle measurement. It's only a part of the angle measurement. We have to actually take the x value that we found, the 16, and we have to plug it in. Don't get lost on what the variable represents. In this case, it does not represent the angle. All right, so we have to plug that in. We get 3 times 16 minus 20. Again, I'm plugging it into the expression that they gave me. We have 48 minus 20, so my answer is 28 degrees. The measurement of angle A is 28 degrees. Briefly, let's go over Pythagorean's theorem. We know it's going to be a squared plus b squared equals c squared, and this is only true if you have a right triangle. And they have to indicate that somehow, whether they tell you it's 90 degrees or if they show a little box in the corner. That's how you know it's a right triangle and that that's a right angle. So we can plug in the values. The c represents the hypotenuse. We can let x represent either the a or the b. It does not matter. The legs can be interchangeable with the a and b. Don't overthink that part. We could put 7 squared plus x squared equals 12 squared. Or we could put x squared plus 7 squared equals 12 squared. It won't change our answer. I'll stick with the second option that I chose. We have x squared plus 49 equals 144. I hope you're familiar with your squares. Okay, that is important to know off the top of your head. We have to subtract. So we get x squared equals 95. We take the square root, giving us a plus minus square root of 95. Now we're talking about a distance or a length. So that's impossible to be a negative number. So I can omit the negative sign. I know that my answer is going to be positive 95, square roots of 95. X equals a positive square root of 95. This is a more difficult version of a hypotenuse problem that will pop up on the SAT. We have expressions representing the two sides instead of numbers, but they still expect us to find out what the hypotenuse is. So stay true to what you know. We know a squared plus b squared equals c squared if we have a right triangle, and in this case we do. All we have to do is plug in those values, the x and the x minus 1, into the a and b. Let's see what happens. We have x squared plus x minus 1 in parentheses squared. Notice I put x minus 1 in parentheses, not just the x. Okay, don't put x squared minus 1 for this term here. Okay, now we have to start to compare what we have now to the multiple choice options. It seems evident that they want us to FOIL out the x minus 1 squared because I don't see any parentheses in any of these multiple choice options. So let's take the time and FOIL that out. We get x squared minus x whoops, I'm all over the place, I'm sorry, plus 1. So we get x squared plus, minus 2x plus 1. So that expression here is going to replace x minus 1 squared. Let's rewrite this one more time. We have the original x squared, okay, my a term. That came from this leg on the triangle. Plus x squared minus 2x plus 1. I still have some like terms that I have to combine. We got 2x squared minus 2x plus 1 equals c squared. We're almost there. The last step we have to do is take the square root of both sides to properly solve for the hypotenuse. That's always the last step in the Pythagorean theorem, is taking the square root. So we have the square root of 2x squared minus 2x plus 1, and that is option D. Here's a phenomenal example of how they use the volume of a square pyramid on the SAT. They're going to present to us 3 different expressions, and they're going to ask for us to find a 4th expression. In this case, we're dealing with the volume of a square pyramid, like I said, so we know right off the bat we're dealing with length times width times height divided by 3. Okay, hopefully that comes to mind like that. They told us the volume is 2x to the third plus x squared, so I can set these equal to each other, the formula and the actual expression that they gave us. We know that the volume is 2x to the third plus x squared. Now we can plug in some of the other variables that we can figure out. They told us that the length is x. So I'm going to replace the L with an x. Then they told us that the height is 3 times the length. So I could take the h, I'm going to erase that, and replace it with a 3x. So now I can actually combine those. I have 3x squared w over 3 equals 2x to the third plus x squared. At this point, we are ready to solve for w. W is what they're asking for. Find the width of the square pyramid. So I'm going to erase some of this, and I'm going to draw back from this point. So here we were on that last step. Right off the bat, I could cross out the 3's because we have no plus or minus symbols on top or bottom of this fraction. I am allowed to cancel the 3's. We have the x squared times w. So what do we do with that x squared? We want to divide both sides by x squared. We want to isolate the w. So I divide both sides by x squared. There's 2 ways to go about that fraction. You could do the GCF on the numerator, or you could recognize that x squared is in both terms. I'm going to use GCF because GCF is a very important skill throughout the whole SAT. GCF refers to the greatest common factor in the numerator. The greatest common factor is x squared. So check this out. I could pull out an x squared from both of those terms up top, leaving me with nothing but a 2x to the first power and then just a 1. Okay, I have GCF factoring videos linked down below if you need more help with that. But at this point, I could clearly see that the x squares will finally cancel out, giving me one last step. W equals 2x plus 1. So our answer is A. Thank you for watching. I hope this really helped you out. Please leave a comment on how I can improve or how I've helped you out. Feel free to request any type of math topic that you want help in. Even if it's not on the SAT, feel free to leave a comment. I'll be happy to help you out. This is Dante with Pat to Math. Thanks for watching, and have a great day.